Hello, good afternoon, everyone. This is tutoring. I'm Lisa Villanueva. I'm here with Leon Nartea. We will be tutoring about normal distribution and normal curve today. You can next slide now. So first of all, there is the difference with the symbols and whatnot. For example, dun sa sample and in population. So like dun sa grouped and ungrouped data, we know the signs there in the sample. It's for mean, it's the X with a line, and for standard deviation, it's S. But for here in the normal distribution or in population, our mean is this thing that sort of looks like a U. That's called mu, as in letters MU. And standard deviation, that is a sigma. That's what the signs are called. It's mu and sigma. And normal distribution. Normal distribution is also called the normal curve or bell curve. It describes the tendency for data to cluster around the central value of mean. So an example of this is the majority of people in a given population are of average height. The numbers of persons who are taller and shorter than the average height is almost equal, and only a tiny percentage of people are either very tall or very short. So you can see here in the data, it's like clustering the amount of people. So like the boxes there is supposed to be a percentage there about how many people is, for example, how tall, how short, etc., stuff like that. And so here, it's another comparison, the difference between mean and standard deviation. So for mean, it characterizes the position of the normal distribution. So you can see here in the chart there, that's characterizing the position of where the normal distribution or the normal curve is supposed to be. And here in standard deviation, it's the spread of the normal distribution. Nakita mo, it's how high it is, and then compared to everything else and stuff like that. That's the difference between the mean and the standard deviation charts. And so next is the properties of a normal distribution. The first property is the mean, mode, and median are all equal. So as you can see here in the chart, they're all equal. And the curve is symmetric at the center, also known as around the mean. So as you can see dun sa center, symmetric siya, as in same both sides. And it is unimodal, meaning it only has a single peak. So ibig sabihin, it's only like one curve. It's not like two curves or something. It's only one peak. There's only one top. And the total area under the curve is 1. And it says here in standard normal distribution, it is a normal distribution with a mean of 0 and a standard deviation of 1. So you should keep that in mind, that that it is a normal distribution with a mean of 0 and a standard deviation of 1. So you have to keep that in mind.
So as you can see here, the standard normal distribution, so it means the normal curve. It always has a standard mean of 0, and it always has an interval of 1, which is the standard deviation. So next is we have the 68, 95, 99.7 rule. So this rule, I'm going to explain it through this sample. And let's say we are measuring the height of a population in a local school. Then it is normally distributed with a mean of 5.5 and a standard deviation of 0.5. So wait lang. Yeah. So you can see this is we're going to measure the height, and this is the mean, and this is the standard deviation. So if we're going to construct this into a normal curve, the mean is going to be at the center, and then the intervals, the increasing intervals of the the normal curve is going to be 0.5, which is the standard deviation. So if we apply the 68, 95, 99.7 rule, it says that the 5.0 and 6.0, it means that the 68%, wait, it means that the I yeah. So it means that the 68% of the population is between 5.0 and 6.0%, zero point zero feet. So and then the 95 here, 95%, it just says that the population is between 5.5 and 6.5 feet. And if we say 99.7%, it means that 99.7% of the population is going to be between 4.0 feet and 7.0 feet. So that is the 68, 95, 99.7 rule. And then next we have the z-score. So the z-score, when we say z-score, it tells us how many standard deviations away an observation or the x is from the mean. For example, if our z-score is +2, then it means that we are 2 standard deviations away from the mean. So if we say the z-score is -2, we're going to say we are 2 standard deviations away from the mean. If we say it is -1, it's going to be 1 standard deviation away from the mean. So the z-score table here, the one Sir Romel gave us, it tells us the total amount of area contained to the left side of any z-value. So for example, this is the z-score table. So we have the negative z-score table and the positive z-score table. So here, the corner, we have the z-value here at the top and at the left side of the table. So here it says the first decimal number of the uh, z-score, and at the top it says the second decimal number of the z-score. So if we let's say we're going to compute for 0.25, we're going to look at the 0.25 here at the positive z-score table. So 0.25, yeah, so here 0.2, and then we're going to look for the 5, which is here. And that is the area of the z-score. And then next, we're going to look for the example that we have for the z-score, computing of the z-score. So here we have the example of the z-score. We have 2 examples here. We have the z. So for the x or observation, we have 65. For the mean, we have 50. And then for the standard deviation, we have 6.58. And for the z equals to 65 minus 50 and 6 and over 6.58, because that is the formula that we have. So to get the z-score, we have to compute the mean, standard deviation, and the x. So we're going to subtract x to the mean, which is 65 minus 50, and then that is going to be 15. So the 15, we're going to divide it to 6.58, and that is going to be equal to 2.28. And if we're going to look for the z-score area, it is going to be 0.9887. So here at the table here, it's going to be going to be 2.28. So we're going to look here at the positive z-score table. And then after looking for the area, we're going to multiply it by 100 to know the percentage of how many probability there is at the left raw score. So multiply it by 100, it's going to be 98.87%. And we can also so we can not only compute for the left side, we can also compute for the right side of the raw score. So to do that, we only have to minus it at 1. So the given area that we have, which is 0.9887, we're going to minus it at 1. That because that one, the one that we have, that is the whole value of the normal curve. So we're going to minus it, and we're going to have 0.01113. And to know the percentage, we have to, yes, again, multiply it by 100. So it's going to be 1.13%. So another example, and we have the x as 45, and then the mean and standard deviation as is. So you can see this example at the last assignment that we have. And so we're going to subtract it again. 45 minus 50 is going to be 15. If it's going to be negative 15, and then divide it by 6.58, it's going to be negative 0.76. Wait. Wait. Whatever. Okay, so correction, it is not negative 50, it's going to be negative 5, which is wrong on my part. So we're going to divide negative 5 on 6.58, and then the answer is going to be 0.76. And then the area you're going to get from the negative z-score table, then it's going to be 0.2236. And then so we're going to convert it into a percentage. We're going to multiply it by 100. We're going to multiply it with 100, and then we're going to have 2.36%. And then to get the raw score, to get the right side, to get the probability at the right side, we're going to minus it at 1 again. And then the answer is going to be 0.7764. So we'll multiply it by 100 to make it a percentage. So we have here a 77.64%. So that is all that you have to learn for the normal curve, normal distribution, and the z-score, the 68, 95, and 99.7 rule. So any questions? Any questions you want to raise? Okay, none. So that is all that we are going to learn for today. So you can leave if you want, since all the lessons that have discussed is finished. You can leave na po.